Okay, so here's probably the first time we've done a little bit of complex reasoning. We're going to have to do a couple of things. Now, let's say you weigh 150 pounds. I guess both of these guys probably do. You can see how athletic they are. And they each run a mile in about 4.5 minutes. 4 minutes and, 4 minutes and 30 seconds. You see they're neck and neck going towards the finish line and have that determined look of an athlete on their faces. So what we want to do is find their average momentum. All right, so what is the momentum? The momentum we said was P equals mv, but we don't really know v now, and we don't know it because we know d, the distance, and we know t, the time. We just don't know what v is. So our first goal will be to find the velocity. So the velocity is the change in x over the change in t, or the change in distance over time, the distance over the duration, the length of the race over the time of the race. Okay, so we know the length, it's 1 mile. We know the time, it's 4.5 minutes. Okay, so that's doing pretty good. We're going to have to convert that, right? We'd probably prefer miles per hour. That's what we normally do things in, so that's 60 minutes for every 1 hour. All right. Okay, so 3 turns this into 1.5 and this into 20. So 1.5, that looks like 13 1/3 miles per hour. Okay, so that's 13 1/3 miles per hour. That's about the speed that running a mile in 4.5 minutes is. Okay, so that's the first part. We found that velocity. Now we're going to take this velocity and put it back in here. So now our momentum is 150 pounds of mass times this 13 1/3 miles per hour. Okay, so this is something we have to actually look at. So that's 1 1/3 times 1500. So 1/3 of 1500 is 500. So that gives us 2,000 pounds of mass times miles per hour. Okay, so 2,000 pounds of mass times miles per hour is the momentum for one of these racers who are pretty close, so they're going to be fractions of a second difference. Now, I wasn't able to find another picture of this guy. He's probably a famous Canadian television presenter or something like that. But I did find another picture of this guy when he got a little bit older. And even though he slowed down a little bit, he's still running pretty fast. Let's see. So, you may recognize him. So there is how to calculate the momentum. Now, if we don't have both of these things and we only have some partial information, in this case we had information that could give us the velocity, then first we have to find the velocity before we can put it into the equation. If we knew the density and the volume, that would allow us to get the mass. But we were given the mass, so we don't have to worry about that. We don't really want to know what Malcolm Gladwell's mass or density is. That's not an important thing. Actually, his mass isn't either. So this is an example about how to calculate momentum. Next, we'll do collisions, or we'll do conservation momentum, which is the basis of collisions.